Let's go to fulfillment, right? So the idea here is if you're making a query to get some fulfillment data, the order tracking status, you want to be also able to get data from the store, which is the order items and quantity and whatnot, right? So this is the source. So fulfillment is your source query, and you want to nest order data within the source argument. Yeah. So what Hasura essentially will do is it will pass this value one to the input argument of order ID, right? So which means it will only fetch the value for orders ID. So that's how this whole query works.
If that's not a selling point for remote schema joins by itself of getting caching for free out of the box, like that's really good. The ability to add that, the ability to also work with remote schema permissions, and everything else. It's really a very powerful way to be able to work and again get things like caching just by bringing in through Hasura first. All right, and welcome to another Data and API show. We are happy to have you back and here at the end of our remote joins and schema joins, database joins series we've been doing over the course of May here. It's a rather interesting series we've been through so far. We've been looking at database, remote schema to database. And we need to cap it off today with the newest introduction inside of Hasura, and that is remote schema to remote schema joins. And so this is going to be a really fascinating talk. To have this topic really properly covered today, I have Praveen joining me. Praveen is no stranger to the show. You've been on many times. My coworker, definitely no stranger to the Hasura community. He's the OG DevRels here at Hasura. But Praveen, nice to have you today. How you doing?
Hey, Jesse, thanks for the intro. All good. Yeah, and I think this demo is super exciting for me. It's GraphQL joins, um, and you talked about all sorts of joins. So this is also like a like an interesting series that we've been doing so far. So yeah, happy to end the series
Yeah,
with an
and
exciting demo.
it's going to be great because it's really got a lot of power behind this functionality, because it's sort of like the final, like the migration story, right? Because Hasura is a very incremental adoption story. Bring in your database, get a GraphQL API, bring in these functions you have running that are doing business logic, put it into your API, join this remote source like a CMS was the case we used in this series, bring it into and attach it to your database. And so now here it's really like not even bringing a database, just bringing two different remote schemas in general and attaching them together. What would be in your mind the most compelling reason, or one of the more compelling reasons of why somebody would say, I'm going to bring in my remote schemas to Hasura? What's the benefit Hasura is giving me on top of that? Why would I not migrate to a database and then just kind of own that myself and then get direct to, I guess, the SQL conversions or whatever instead of this proxying behavior? What's sort of the use case here of why somebody would do this?
Yeah. So as you mentioned, I think multiple use cases, but to start off at incremental adoption of Hasura, or into your GraphQL journey itself. You have an existing GraphQL server, and then you want to migrate to a database kind of a structure, which is Postgres, and Hasura gives you instant APIs, right? So first use case, you want to move to Hasura, but then you don't want to move the database bit yet. You're probably not on Postgres. You're probably on a different database. So you want to slowly do that over time, and so that's one particular use case. Second use case is you need all of the other features other than writing a GraphQL server, which is, let's say, I want authorization on a GraphQL server. I want security monitoring, rate limiting, and other production ready features, day two features, which I need to write a lot of code for if I'm writing my own GraphQL server. Right, so that's a pretty good use case, and you can just add your GraphQL server as a remote schema to Hasura, and then just configure everything declaratively through Hasura's metadata. So that's a pretty compelling use case for me. And obviously the last one would be, hey, you have this joins now. Now I can join between two of these GraphQL servers. I can join between GraphQL server and database and vice versa. So this opens up a lot of use cases where I don't need to actually replicate data. In cases where I don't need to, I can just join data. I can just on demand request data from all of these sources. So that's the joins use case that we've been talking about in the last few episodes, including the remote schema to remote schema joins that we're going to talk about today, right? And also, not every use case is database compliant, in the sense that if you have a SaaS service like an external vendor API, which exposes an API that you want to call, or do some processing of data on, it's not possible to just use Hasura and then just say put it on Postgres, right? So you have all of these vendor APIs, you have all of these internal tools in your backend teams, in your Microsoft's architecture, which are written for a very specific use case, which is not even using a data store like a Postgres, right? Which is just using a bunch of external APIs and aggregating data for a different use case, right? So all of these custom logic stuff, all of them comes into this GraphQL server. You add them to Hasura and then add the value add of Hasura by just putting it out all of the authorization, caching, and rate limiting, and all of the security features.
Yeah, because I think that's probably one of the interesting parts about Hasura is it really isn't just about the instant GraphQL API, which is a huge portion. Like it's great to
Right.
bring in that database and you get a great GraphQL API, but it is a lot about also the authorization. It is a lot about built-in caching when you're using cloud. It is a lot about tracing and observability. And so when you're bringing in other tools, or you've already got an existing Apollo server set up somewhere, or other tooling in place, or you've got maybe a GraphQL that's adapter on a Mongo instance, for example, like
Right.
you want to be able to leverage your existing data set to get the benefit of a unified GraphQL API without necessarily having to go in and own. Actually, in other federation concepts, I'm not calling out any vendors in specific here, but in other federation concepts, you have to modify the underlying GraphQL API. You have to say this connects there through these different parameters. And here, without even having to write a proxy layer, you're able to just bring in all these different providers because GraphQL has been around for a little bit now. You can bring in all these providers and go ahead and say, I want to actually just connect these on this edge here, and then you get this unified API and are able to ship that single API to your dev team. So yeah,
Yeah.
pretty cool use case. That's
And
yeah.
just to add to that, sometimes you don't even have control over the GraphQL API that you're adding.
Yeah.
Let's say you want to add a GitHub API, which probably doesn't support the federation spec that you're talking about from a different vendor tool. Um, then you don't have the option of actually merging data between those APIs, right? So we have a lot of these CMS services which expose GraphQL APIs these days. Now, if there is an option for me to actually make an API call from Hasura, merge data, if that is possible, then that is a more compelling use case than because you don't have control over what you can change on the upstream API if it's a vendor that you don't control. So, and that's
Yeah.
that's also like a popular use case.
Yeah. Yeah. Totally true. So let's see. Just, I mean, we've done this bit before, but let's go ahead and actually do a walkthrough of connecting these different pieces together. I'm going to bring your screen here onto the show, and you've got an example use case here that I think is pretty common for where somebody might come across this. Why don't you talk through what our two different APIs are here that we want to connect, and we'll see just
Mhm.
how fast that actually comes together.
Right. So we have this repo. We have a simple graphical joins example here. Here, the use case is our favorite example is an e-commerce example, right? We have like a store API which gives you the items in a store. and you have like a fulfillment API which lets you track the order status. So you have some orders being placed in a store, and you have a tracking status which can be on a different GraphQL server. So this also means that there are two different GraphQL servers being, let's say, being maintained by different teams in an e-commerce setup, uh, microservice architecture, two different teams pushing code, but in GraphQL, right? So you have two servers here, store and fulfillment. Now, if we look at the schema for the store service, it's pretty simple. You have an item, you have order, and you have like a query which lets you query the item and orders, right? So it's a simple schema which lets you query the items and the order of the store. And there's a fulfillment service which lets you track the status. So there's like a query for tracking fulfillment when you pass in the order ID. So for a given order ID, you will know what the status of the order is, and that is the only purpose of this particular service. And the store service just lets you query for items and orders, right? Now we see that in the schema, in both of these schemas, if we closely look at it, order uh, is common in both of these. There is a pattern here. There is the order ID which is being used on both these schemas. So that the store service uses the order ID, which is an integer, and also the fulfillment type also has an order ID, which is again which is the same value that's being used in the previous service, right? So that's an assumption that we make, that hey, the order ID is actually the same order ID across. If not, then there are other problems that the application needs to solve. So the assumption is that we have order ID as the common parameter or a field being used, and based on this, we have a use case on like, let's say, a front end client, which is on an order status page. Come to an order status page and say that, hey, I want to track this order. I give the order ID. I know that the status is in progress, or let's say delivered. But I also want to know the metadata of the order, like what is the actual order was all about, like what are the items in the order, or maybe different items have their own status, right? So typical use case would be you will make multiple API calls on the front end. You will make a call to fetch the order status. You will also make a call to fetch the order items on a separate API call. Now with GraphQL, because you can now do nested fields in your query, and your backend can take care of fetching data from different sources, you should be able to now say that, hey, I need fulfillment data for a particular order, but I also need the order details, which is from a different server, right? So GraphQL now lets you do that, and we want to be able to join this data somehow magically, and Hasura lets you do that with the configuration that we'll see in the demo, right? So that's the schema for you. We have both of these schemas deployed on let's say Heroku. So we have two GraphQL server endpoints that are available, which we can track. So let me actually open up um, the public console. So we have a cloud.hustle.io/public graphical. For those of you who are new to this is just a API Explorer version, which is just not having the console bits, but just allowing you to access GraphQL endpoints and then make queries. An online version of GraphQL is this UI, right? So what I'm going to do here is, I think Heroku's probably also
Needs to
in
warm up,
sleep.
maybe.
Yeah, it's in sleep mode. It's a cold start, so I'll give it a little bit more time. Meanwhile, let's look at the GraphQL joins example again. Right. So just to
Because
go
I just wanted
inside.
to add some additional color there, like, because it is a very common use case where, especially in restified services, where you've got a fulfillment platform and there really isn't a good mechanism for tracking what it is that's shipped, right? Because you've all been there when you call up to customer support or something and you got the order number, and and then you have to give them like the product ID or whatever. I mean, you're just like, hey, I have a question about the shirt, right? And they're like, well, what was the order or the charge number on the shirt or something? And it's because they don't have there's no connection in the system. They're having to see this random identifier that was the specific item. And sometimes you're trying to be very specific, but like, imagine how much you can even just improve customer service when it's kind of like, oh yeah, I see this order and I see the items and the little picture next to it about what it is that you were doing. Like that for a help desk person, or even just for a person going and modifying their own orders, it's huge because it sometimes kind of sounds a bit more like a contrived example, but these are the constraints of why sometimes this system and this infrastructure is the way that it is like, yeah, we don't have great mechanisms, and it's really a waste of development time to try to talk about orchestrating multiple calls here and there, whereas now we could really say, hey engineers, can you just go ahead and bring up the product title along with the rest of it, and like that's on
Right.
the data, that's on the graph, that's on the actual API endpoint. They just have to add a couple of nested fields. Yes,
Right.
it is making these additional calls, but in terms of orchestration, in terms of management, in terms of how you would orchestrate these API calls on the front end, that's not there. That's just gone.
Yeah.
Everything the way that is one request out, the first page of results, and you've got all the data, and that just really does actually create a pretty substantial difference for a user. Yeah.
And also like this the moving the logic from front end to back end also makes it easy and less error prone, because transformation on the client is a lot of work, and is
Yeah,
also more
passing the
error.
identifier,
Yeah.
right? Because you have to say, well, take this
Yeah.
identifier now, pass it in as the parameter to the call to this other service, and that's just happening opaquely in terms of the
Yeah.
API for the front end. It's saying, I just want that nested data. I don't care
Yeah, I don't care
about
the
the behavior.
mechanism
Yeah,
of
yeah,
how the API is actually made, right? So
yeah.
yeah, basically switching context for the front end developers to just push it to the back end developer, saying, "Hey, you fetch me what we want on the client. I just want this particular format of data," and GraphQL gives that power, and that's the beauty of GraphQL, right? So yeah, so I think that's one of the use cases, and I think the other use case I would also say is that for admin dashboards, which and analytics reports and reports in general, which will require metadata from different parts of your schema. If you're tracking order stats across a week, you might also want to know which product was the most ordered and whatnot, right? So in those cases, obviously, you will want to merge, combine data from different data sources, and then do some transformation and then show them on the UI, which is a lot of client side work in a way. If there are multiple API calls involved, obviously you can write your own server which just does this for you, but it's again more endpoints to be maintained for the backend developer, right? So
Mm,
yeah, so that's a lot of work that's being solved with this particular workflow of Hasura.
mm. Yeah,
Cool. So
cool.
I was
Is
thinking,
Heroku?
yeah, so I was thinking let's actually go ahead and create a Hasura project itself.
Yeah, yeah.
As yeah. Okay, I will just go ahead and create a project.
That's
Um,
pretty bold DevRel move there. Because you and I are both not based in the U.S., but choosing the cloud
choosing
region, U.S. West, just like what's the furthest away from me, just to try to up that latency. Yeah, that's bold.
right, right. Yeah, I've always done this, and I don't know why I do this, but I still keep doing it. But yeah, I think as long as I have some latency coming in, it should be fine.
I mean,
So
it's minuscule, but I always love it when
yeah,
when developers are kind of like, okay, which region are you deployed in? I'm like Frankfurt. They're like who's deploying stuff into the Frankfurt cloud? That's just there for GDPR benefits.
yeah. Cool. So I'm getting an error. Um, this is our typical debugging
Yeah, this part will cut
workflow.
out. All right, we are back. So we had a quick little Heroku instance problem. Like, can we just like pour one out for Heroku here real quick? I'm just like they were the ones that got it all started, developer experience and all. So yeah, not been the best month for them, but anyways, we have a working solution in place despite the Heroku instances going down, and so yeah, what's our fix here for getting our little microservices up and off the ground?
Yeah, so I have the GraphQL service running on my local machine, exposed to the public through local tunnel. So this is the URL slash GraphQL. I'm going to connect to this endpoint. This is going to introspect the GraphQL schema, and this gives me a bunch of queries that we saw from the schema that we initially saw in the repo, right? So let's actually make a query. Let's say order one. Let's fetch the ID. Let's fetch the item, whatever the fields over here are, and let's make a query. And there you go. So we have order details coming in from this store API. Right. So let's move to the next API, which is the fulfillment API. So now we have order items. This is a separate GraphQL service. Let's actually look at the order status API. So this will be a different endpoint slash GraphQL, right? So this is Breezy uh, endpoint prefix, and this is again, okay, the difference here. Okay, I probably copied the same URL. Let me go to Freshbirds. Cool. This is the difference.
Sometimes I feel like the Mac does that, right? It's just kind of like, did you really want to
Yeah,
copy a new value, or we just want to look at the same one that we copied like
same
10
with the
minutes ago?
clipboard. Yeah, and with the universal clipboard, you get copied values from all sorts of platforms, including the iPhone. So yeah, it's a little sad in that times for demos. Um, but yeah, here we are. We have this Breezy thing, which API, which gives you the order items. We have this Freshbirds API endpoint, which gives you the fulfillment status. Uh, and let's look at the fulfillment status for the order ID 1. Let's get the ID, order ID, and status. And there you go. So you have status packing coming in from the server. Cool. So we now have two individual servers running and giving their own sets of data. And as we mentioned before, the common parameter here is the value of order ID. So the order ID here is 1 and the same order ID here. We somehow need to magically merge this data without writing any code and modifying any of these services, right? So let's do that. So the first step is we go to Hasura and then add this as a remote schema, right? So let's go to remote schema and then say, hey, this is the store API. This is the GraphQL endpoint. Forward all headers. It doesn't matter for this demo, but now let's add a remote schema. So now we've added a store API, right? Now let's go ahead and add a fulfillment API, which would be the Freshbirds API endpoint. Again, forward all headers, add a remote schema, done. Now let's go to the API Explorer. We'll have the combination of these two servers. So we have now stitched the two servers. Typically, we call it schema stitching back in the day, where we add two GraphQL servers as a remote schemas, and then you get a unified graph with the stitched schema, right? So this is the stitched schema. You have the fulfillment queries, and you have item orders coming in from a different server. So yeah, and this is a feature request for the Hasura product team that, hey, I want to know which particular mode schema this particular query is coming in from. So I'm going to do this on the product channel. Cool. So now let's make the same query. Let's make the fulfillment query, order ID, status. We should get back the same data, same stuff. So it's all working. It's all working from the Hasura console, which means if you make a query to this particular endpoint, which is a Hasura GraphQL endpoint, you should now be able to make these queries and get back this data. Now, the implementation detail of the two individual GraphQL servers will go in the background. We don't need to worry about that anymore. So we just need to contact this endpoint from the front-end app. Right, so again, same values, the data coming in from the second server. Cool. So now we have order fulfillment. Now, as we mentioned, we need to establish a relationship. Let's go to the exciting bit, which is the remote relationships. Right. So let's go to fulfillment. Right. So the idea here is if you're making a query to get some fulfillment data, the order tracking status, you want to be also able to get data from the store, which is the order items and quantity and whatnot, right? So this is the source. So fulfillment is your source query, and you want to nest order data within the source, right? So we'll add a relationship which will let you do that. Um, so you can see here that there is a remote schema relationship, uh, and there's a remote database relationship. So you can do remote schema to remote schema or a remote schema to a remote database. And I think the other use case would have been covered in a different episode. Cool. So
Yeah.
now this remote schema to remote schema, the other remote schema is basically the store API because the order information is available there. And let's name this relationship as order, and let's select the source type as fulfillment, and let's select the remote schema as store. And let's go ahead and see the order and the argument. So this query items order and orders, all of these queries are coming in from the remote schema called store, which is the reference remote schema. What we're trying to do is we're trying to establish a type which can be mapped from your source schema to a target remote schema, to a reference remote schema. Source is fulfillment here. We're already on fulfillment. We're in this tab, and we want to merge it with store. That's just the workflow here. And inside store, we know that we want to merge with the order data. So we know that this is the order query, and it has an argument called ID. And the source field value would come in from order ID. And the fields that you see here are coming in from the fulfillment uh, types. And the query for fulfillment will give you the result of ID, order ID, and status, right? So you have these three fields coming in for the fulfillment query. And in this particular query, we know that order ID is the parameter that we want to merge with and then map it with the date. So order.id mapped with the order ID, camel cased order ID from fulfillment. Cool. So let's add this relationship now. It might seem like a pretty complex UI, but after all, it's just mapping types from one source schema to one reference schema. And then you're just defining this configuration, which is declarative, right? And hence this bit of magic mapping lets you worry about making the query and not worry about modifying services and upstream logic and whatnot, right? So the servers can still be independent. In fact, the engineers who wrote code for order API and the fulfillment API doesn't even need to modify any of this. It doesn't even need to know that somebody's actually joining this data that they've been writing, right? So that's the configuration bits. This is what we've done so far. Now let's go to the API layer, right? So let's make a query. We'll do fulfillment. We pass in the order ID, the same order ID, the ID. Now instead of the order ID and status, so basically typically this is the default query that we made, which was just giving us the order ID. Now we don't need just the order ID, we need order details, right? So we want to expand this in a nested query. So we make the order ID again, and then we have a bunch of line items that we want to fetch, including the item name and price. So we're basically fetching the entire graph of the order server which exposes a bunch of these fields. And we're nesting it all under the fulfillment API. So this is the order thing that's coming in from a different server. ID and status are coming in from the same fulfillment server, right? So what essentially is happening behind the scenes is that when you're passing this order ID one as the argument for fulfillment, and because you've configured uh, the filter, the argument for orders ID to be mapped to this order ID,
The
what
input
Hasura
arguments you're mapping, yeah.
input argument, yeah. So what Hasura essentially will do is it will pass this value one to the input argument of order ID, right? So which means it will only fetch the value for orders ID. So that's how this whole query works, right?
Yeah, that is really like, I mean, the ability to connect those two pieces together like that. And then again, like you're only, I mean, because if you were to just do all fulfillments, for example, you wouldn't even have to pass in an input argument. You're just selecting one, but you'd be able to also just do all of them, and for each of the sub fields it would actually pass that input argument and be able to give you everything you're looking for. And that's a really strong way to be able to build content. I wanted to just to add a quick note slash correction, like you said, schema stitching, we had a stitched API, because this is not a stitched API, in that if you use this federated API, if you were to query against a service that was down, the rest of your API is going to stay up. And that's one of the most critical differences between a federated versus a stitched API, is that if any of these services go down, you're just going to get back a null response. But you'll still have the rest of your API up and running, which is partially why this becomes really helpful, is that you have this robustness that it is it is not it is not generating new types under the hood. It's
Right,
referencing the types and referencing the schemas that you've already got, but it's not creating some sort of new schema definition based off of that. And this would support caching. This would, like, because we're on cloud here, this would support caching. This would support all kinds of really powerful primitives of layering on that Hasura stuff we talked about at the beginning of the show.
yeah,
And this is also very understandable. One of the big stories we get inside of Hasura is sort of a data ops use case, where people are trying to connect a lot of different disparate data sources to be able to see, what's my fulfillment timeline versus like the time window for analysis of when it was ordered versus when it was delivered versus which touch points along the way. And being able to get a unified API like this, you can ship this to your biz dev unit and they can understand this in a really simple way. This is so much easier to understand and reason about than like a SQL statement with 30 joins, and this is a much more declarative way to actually be able to work with this and be able to reason about what it is that you're looking at. So super powerful. It's a really really exciting new tool to add to the Hasura toolkit for just so many different use cases. And
yeah,
yeah.
yeah. One of the new features among a bunch of other powerful features that we already have is what I would put GraphQL joins as. So um, yeah, just going back to the demo bit here. So um, as Jesse mentioned, the input argument is being mapped here, right? So I was just trying to open up the order query separately. And if you can see this query, you can see that there is an input argument, which is ID, which is accepted, and you can pass in some values. So technically what Hasura does is once you create a relationship between the fulfillment and order based on the ID, once you pass this particular value, the order ID 1, it will technically pass this value as the value for orders input argument ID, right? So this will mean that the actual data for that particular order is getting called for. And then the reason why you don't actually pass in ID 1 here is because Hasura is doing that for you and then mapping that value automatically for you instead of you doing it every time you're making a query, right? So that's the magic that's happening, and that's all declarative. We just saw the connection that we made on the relationships tab. So that's all. That's all we're doing there. And let's make a query now with all the join data. Now it's going to make a call to two different local tunnels, which is running on my local machine. I
So it's
suppose.
going to going to Bangalore, going back to US West,
I
and it's doing for multiple requests as well. Because in this case with joins, the one thing that we're not able to do is to leverage any sort of clever batching querying, because in this case it has to do a special query for each nested one. So it's taking a little second to do that. I wonder if we could throw caching on that though and see what sort of an improvement on reading would actually be. Um, if we, I think you have to do a named query at the top, and then
Yeah.
you put the
So
cached at
just
the.
to query get um order data and
And then it's at cached after the named
yeah,
parameter. Yeah.
and then we'll give it, let's say, 60 seconds. And there you go. So this is just a directive called at cache that we add to a named query. And then I think the first query is still going to
The
take a
first
little
one
bit.
caches, and then the subsequents
Yeah.
are
And
are
you can see
cached.
that
Yeah.
the cache directive it's appearing over here. The console is tracking it here.
We turn off
So that's
our
working.
faces here so we see just the full coding if I know how to do that.
Right. So I will probably
Whatever.
minimize the screen. I'll probably
That's
zoom
okay.
in. Yeah. You can see that the uh, cache directive is being used, and you can see the response time is 290 milliseconds, and it was definitely not 290
It was
milliseconds.
definitely not 219 on the first one.
Yeah, and we can retest this again by removing this at cache parameter, then making this call, and you can already see that the response time is 1441 milliseconds. So let me include the cached directive again. Again, the first query might still take
It's
its own.
caching, right? Cache is the first
Yeah,
one, so
yeah, cache
1700
the first one.
milliseconds, and then the
So
subsequent
yeah, you get it.
is
So you get
270.
it,
So,
yeah,
like,
almost like
if
7x,
that's
8
not a if that's
improvement.
not a selling point for remote schema joins by itself of getting caching for free out of the box, like that's really good. you know, the ability to add that, the ability to also work with remote schema permissions, and everything else. It's really a very powerful way to be able to work and again get things like caching just by bringing in through Hasura first. So that's a really great way. The schema permissions, yeah, it's we gotta turn on environment variables. It's still an experimental feature for the time being, but yeah, it's a really powerful way to work. I mean, there's not much more to really show about it, right? It's pull in the schemas,
Yeah,
make the connection, map the input arguments, and done. The use cases are there's lots and lots, and we could talk about it. Um, at pretty much ad nauseum, but it's something where whether you're doing data ops, whether you're doing bootstrapping a quick application, whether you're trying to sort of say how can I bring in this existing service that we've written and now bring it into maybe a new cleaned up data that you're working on. So you've got some sort of a hacky, this was the overnight brainstorm that launched the ship, and then you've got your new database that you actually took your time getting your schema, and you still don't want to lose any of the existing data or some of the existing concepts you had in the old data. Maybe you can just bring that in. So there's a lot of use cases where this story of joining across data sources makes sense. I think the database to database one was a pretty cool one where we had done transactional databases to time series databases. It's really impressive, and to be able to have these kind of tools at your fingertips, because it allows you to just stop thinking about the how, and it really allows you to focus on that why part. We're building here, we're builders, we're building tools, we're building applications, we're building solutions to problems, and you can start to really go back to think again. Like, I don't need to have really obscure join tables when I have metadata powered relationships. I don't need to have 1,000 resolvers for all of my CRUD behavior when I can just generate that stuff because it's part of my database schema. And so that's kind of what Hasura is doing here, is it's saying, let's focus on the problem and figure out which level of tools and which level of meta detail here we can abstract away. and say, we don't need to rewrite cache for every project. We don't need to generate, or we don't need to create resolvers by hand for CRUD behavior. We don't need to do, make everybody bring their data over and annotate their schemas to just do a remote schema join. So this is kind of the full story here that Hasura is really enabling, is this powerful building concept. And we're super excited to see sort of what you all build, which data sets you're going to start to kind of mix and match together, because it's that I'm going to drop the 90s buzzword here. It's that synergy between two different remote schemas and different data sources of where you really start to create value. Is I'm taking X and I'm mashing it with Y because nobody else did that, and now I have this new product, and it's pretty exciting. So, any
And
closing thought? Yeah, go ahead.
yeah, just to add, I think the the fact that uh, the feature GraphQL joins exists, like you can join between all of these data sources, gives me that comfort that, hey, probably I don't need to join this data today because I don't have a use case yet. But maybe down the line, once my schema evolves in all of these different services, and then there is this one particular day, I want some analytics data, I want some stats and reports from all of these services. Now it gives me comfort that, hey, Hasura lets me do that already. Hasura lets you join between these services, join between the databases, and vice versa. All sorts of combinations and permutations you'll be able to do, and that gives me a comfort that I can quickly add a remote schema today and incrementally adopt to Hasura, but then also knowing that later in
Yeah.
the funnel of my application building, I can still end up joining them without modifying any of the code that I've been writing so far, and I'll be writing in the foreseeable future, right? So that is also a pretty compelling use case to move to Hasura and then use all of these features incrementally as well.
And selfishly, it also opens the door to a horizontal Hasura model too, because all the metadata, you could have a much wider and bigger scope of your project all managed in metadata. You could
Yep.
also actually have more microservice focused instances of Hasura where you've got things just around warehousing in this Hasura and things just around whatever in this Hasura instance. And you're able to also use a third Hasura instance as sort of the joining layer where you're able to actually sort of compose Hasura instances. We have customers that do exactly that functionality. They have warehouse management, they have delivery, they have biz ops, and they have all these different services, and they're using Hasura in each of these places, allowing them to also mix and match, skills and familiarity with the product around their entire business. So yeah, that's that for the show on this side. Praveen, thank you so much for coming on and showing us this tool here. I think hopefully people will really see the benefit of what's available there. We would love to see what you all build. Definitely hit us up in the comments and let us know what it is that you're working on. Join us on Discord. We will be breaking for the summer with this last show, so go out and join all the things over the summer. But we'll pick up again in the fall and be able to have a look at what the next round of features. We have a lot of really powerful tools coming up inside of Hasura, and we're pretty excited to see what the shape of the ecosystem will be at the end of the year. So thanks again, Praveen. And any last thoughts from you or words of wisdom or
No, I think this was a good demo series that you've done, and I think all sorts of use cases are possible. And I think we are happy to listen to the community to see what are the different sorts of joins that they are wanting to do. So far, I mean, the e-commerce is our favorite example, but also I think we need more and more use cases that people are using joins for, or probably will potentially use it in the future, because not everybody wants to join data today, but they might have a use case in the future and they might be thinking whether Hasura
yeah.
supports it or not. But now today, Hasura supports it. Now, what are your use cases? Bring it on. So,
All right. Cool. All right. You heard him. Bring it on. We'll see you in the end of the year, and have a happy summer, everybody. Bye.